It's a real pleasure to be talking about GeoPandas here at SciPy. This is a project that was born last year at this time. So last year we had a mini symposium and I taught a tutorial on geospatial data in Python. And a couple times over the course of the tutorial, in questions and through the panel, questions came up about how you work with geospatial data and why doesn't it work the way that some other things work in Python. Why can't we just use the same tools to work with geospatial data that we use to work with other kinds of data in Python? We're used to working with arrays and tables and various kinds of data structures. And why doesn't geospatial data work the same way? And so, in fact, the name GeoPandas got coined. I think it was actually a question in the audience. I don't think it was my coinage. But someone came up with, why isn't there a pandas for geospatial data? Where is GeoPandas? And I thought that was a really good question. And I started hacking around in the evenings in my hotel room during the conference last year, and I was like, I wonder if you can subclass pandas data structures, series, and data frames. And maybe it's not a good idea, but let's see if it works. And by the end of the conference, a couple of evenings of hacking, I had something that I thought was going to work. So it's the prototype of what became GeoPandas. So now, a year later, I'm going to show you sort of what that project has turned into since that time. And I think it's at the point where it's a robust and useful thing. And I'll show you a little bit about what it does. So, what are we trying to do with GeoPandas? We'd like to make working with geographic data as easy as working with other kinds of data in our standard Python data analysis tools. And there are other tools I'll acknowledge here that have gone some part of the way, but at a high level to organize the geospatial data, there wasn't really something that did that in the way that I was interested in doing. And it should be something that works well with all the other existing tools, proprietary and open source, that work with geospatial data. Those include desktop GIS programs, the commercial ArcGIS, and the open source QGIS are the big ones you might know. With geospatial databases, PostGIS, but other databases have spatial extensions that are useful and deal with spatial data. And another interesting realm these days is web maps. There's a lot of interesting stuff going on, tools like Leaflet and D3 and Google Maps and Mapbox and all kinds of tools that show us maps in the web browser. And getting into those tools should be easy as well. And then finally, the Python data ecosystem. Starting with NumPy and the tools built on that, and particularly the Pandas ecosystem that has really made working with data a great interactive, powerful experience in Python. And to leverage that and combine it with these other tools and this kind of data is something that I was interested in doing. So just generally about the GeoPandas package, it's written in pure Python, so there's no compiled libraries internal to GeoPandas. The dependencies have a lot of compiled things, and you'll see that. But if you can install the dependencies, you should be able to install GeoPandas. That's a big caveat, but as many of you know, but we're working on those kinds of things. We support basically Python 2.6 and up. So it fully supports Python 3 now. It's running tests up to 3.4 and continuous integration tests, and it's a single code base that supports Python 2 and 3, and I'd like to keep it that way. And it's built on a number of other packages that make it possible to do this kind of high-level library, particularly Pandas. So Pandas gives you the fundamental data structures that we use, and I'll talk a little bit about those. It supports fully Pandas 0.13 and up. It'll mostly work with 0.12, but if you have the choice to upgrade, it's a little bit better and better supported for this kind of thing. It depends on some of the geospatial libraries, including Shapefile, which does the geometry part of this, which is fundamental. Combines that with Pandas. Fiona, which is a layer on the GDAL, and particularly OGR tools that do file input and output. So now Pandas is sort of 3 libraries deep. GeoPandas is 3 libraries deep in the layer on these compiled libraries that do the reading. But this makes loading shapefiles and other geospatial data seamless in GeoPandas. It does map projections, PyProj for converting between different coordinate reference systems, so you can go easily from latitude and longitude to a particular map projection, or from an arbitrary map projection to another. That's handled, by the proj4 library under the covers with the Python layer and PyProj. And then there are plotting capabilities with matplotlib and Descartes, which is a helper library to show the polygon patches, and that gives you a nice quick output of your results. And then there's some optional things to do other parts to connect to the PostGIS database. You can use these libraries to do that connection, and GeoPy does geocoding, and I'll talk a little bit about that. All right, so all of these things, you can install all of these things and work with these tools directly, and that's no problem. GeoPandas is meant to be this high-level tool that you can use. It makes it easy and seamless to work with, to use, leverage the infrastructure of all these things and have things that you can work with interactively and get in a quick, easy way. Okay, so what does GeoPandas do with all of this? Geometry operations, fundamentally, and those are done by Shapefile internally, and it essentially parallelizes them to distribute them across arrays, series of geometries instead of individual geometries. It does data alignment with the indexing power of Pandas, so comparing one series to another, if they have an index, it'll line them up properly. That's all built into the Pandas indexing system. The coordinate transformations, the input-output, easily creating data structures from, not just from files, but from database connections. And then fundamentally, it will output anything that you want into GeoJSON. And then that's a very portable format for outputting things into other systems, into web maps or whatever you want, right? So that's the set of tools that it has, and there's also some basic plotting functionality to get a quick look at the results. Okay, so how do we get Pandas to do these things that it's not meant to do? Right, so Pandas is meant to work with numeric data, strings, a few other kinds of data types that it understands, right? But it doesn't know anything about spatial data. So that's what GeoPandas had to do, and to do that, it subclasses the main data structures of Pandas. I was advised early on that maybe this isn't a good idea to try doing. I forged ahead to see, how far we could take that idea of subclassing the Pandas objects, and actually, because of some architecture changes in Pandas itself, that's gotten a lot easier. And now I think it's pretty robust to actually subclass these objects. So, if you're familiar with using Pandas, and I think most people at this conference are, if you're not, look into it because it's a really powerful tool. The main data structures that are relevant here in Pandas are a series, which is just a 1D set of data that can be indexed. A data frame, which is a table, a two-dimensional data set, and that has rows and columns that may be labeled, indexed, that you can use, and higher dimensional objects, a panel, which is a set of data frames. There's even a 4D panel experimentally. But those are the main data structures. And now, using those in GeoPandas, by subclassing the Pandas series, there's a Geo series, which is a 1D series that can only contain geometry objects. Right? So the same Pandas index applied to geometric objects. Okay? So that's all a Geo series is. And then it has some special methods and attributes that you can use to work with that data. A geodata frame, which is the 2D equivalent. One column of the geodata frame can be referred to specially as the geometry column that defines the geometry of each row. And then each row, if you're coming from the GIS world, each row is a feature. It has a geometry, but it also has attributes. And those attributes are the columns of the data. Right? So you can have whatever it is, census data. So you could have the geometry column could define the outline, the polygon that outlines a census tract. And then you could have a column that defines what the population of that census tract is, and some other statistics in other columns. Right? So this table can have information in the tabular form. You can look at it as a table, and you can output it as a GIS object, right? So you can work with it in both worlds. Then obviously the next extension would be a GeoPanel. I haven't had a use for that yet. I could imagine some uses. It wouldn't be hard to implement if we want to do it. But you know, so the equivalent would be a GeoPanel would be layers. Each data frame within a GeoPanel would be layers within a map. And that's certainly something possible if there's a use case for doing that. That's the obvious extension to take it there. Okay. All right, so Shapely does geometric operations. This is from the Shapely documentation, operating on individual geometries one with another. And GeoPandas extends that so that you can operate on whole columns of geometries with another column of geometries, right? So a geoseries on a geoseries to union each individually by matching up their indexes, or to operate on an entire column on a single geometry. Both of those work. If I have time, I'll show you a little bit more examples, but I'll point you to some examples online to look at this as well. Loading data from a shapefile. I think this, even if you don't do anything else with GeoPandas, I think this is probably the easiest way to get data from a GIS file into Python and in a form you can work with now, is to load a geodata frame from a shapefile or several other standard GIS vector formats anything that Fiona can read, essentially, will be loaded into a geodata frame, and that will give you a table that has a geometry column. You can work with the geometry column, but maybe you just want to see the numbers, and then there it is. You can work with that just in like any other Pandas data frame, but then you also have the geometric methods on it with the GeoPandas geodata frame. It has quick plot outputs. There's just a plot method, just like other Pandas objects. So you can show an object on a map in its own native coordinate system. This is a map of the boroughs of New York City that I use for examples. And the axes are in feet because it's a projected New York State plane coordinate system that's in feet. Geometry built in, so we want to take the convex hull of each of the boroughs. You can apply a convex hull as an attribute. It's a computed property of the boroughs data frame, and then plot that, and you can just chain the calls like this and show that. Any other Shapely operation is just built into the data frame into the series. A few other examples. Let me quickly show. I'm going to skip. Okay, well, this one. I'll skip the series example. This is online if you want to see it. But I'll show this quick example of working with a shapefile. So here's some imports to get set up, and I've got a shapefile that I downloaded from the Texas Water Development Board that shows the natural regions of Texas. Okay. So to load that into a geodata frame is just here, geodata frame from file, this file name that I've already downloaded, and it's this big table like this, right? So showing you in the IPython notebook, we can see there's a geometry column. That's just the text representation of the geometry column, but these are stored as Python objects that we can work with. And then we can show a plot there, display that. We see there's this little offshore region, and that's actually where the region is none. So if I do a little filter operation and I pick where regions is not null, use the pandas not null method and plot those, I can get rid of that little offshore bit of Texas, and that works out better. And then I'll show you one little trick that's pretty new, but this is a tool that passes a matplotlib plot off to Leaflet, which is an open source JavaScript plotting library. And it takes an existing plot here. We'll just generate the plot with GeoPandas, and then with MPL Leaflet, display that plot. Okay, just passing in that figure from Matplotlib, and run that, and this will, I think, there we go. What? Yeah. Okay, and that shows you an interactive map in the IPython notebook. If I make this, instead of display, I do show. Let's try this. This will spawn a separate window. There we go. Okay, so then this is now an interactive leaflet map of these geometries plotted on that background. Yeah, question. Sorry.
I'm so sorry, but can you control the opacity of that layer? And what's the base map that you're using?
Yeah. What is the default tile? I mean, it's an OpenStreetMap layer, but I'm not sure exactly what layer. But that's where the source data is from. But you can control that with Leaflet. I don't know how many of the parameters are exposed in MPL Leaflet, but the MPL Leaflet library is the connection between Matplotlib and the Leaflet library there. So the point here is that GeoPandas works seamlessly with these other tools, and this is a new one that just works well with it, right? Because it works with Matplotlib, and then passing off JSON to other libraries as possible as well. So I see we're just about out of time. Let me wrap up the. Whoop, there we go. Output to GeoJSON. There's geocoding. We have a few things on our to-do list, and in particular, we'll have some sprints on Friday and maybe Saturday. If you're interested in contributing, we'd love to have more hands to clean up some of the things about GeoPandas and get other use cases and finish these things. And let me end with the thanks to the contributors who have contributed other things to this library. A couple of these guys are here today, and hopefully we'll get to sprint on this on Friday. So thank you very much. And we have a little bit of time for questions? Okay, thanks. Okay.
So we have plenty of time for questions. If you have a question, raise your hand. I'll bring you the mic. Here's one.
Yeah, so most of the examples you have are fairly static. Is there anything that, or any facility for dynamic, you're flowing in data from some source and updating the map, updating an object on the map, like at 1 hertz or something?
Not really, because that's tied to Pandas. You'd have to extend the Pandas data frame each time you do that. So it's not a particularly efficient operation to do. So that's not the main use case it's aimed at, right? There are probably better ways if you're streaming data like that to send tick updates into that. Yeah.
So each geo data frame, is that restricted to a particular like polygon or point, or are they?
Yeah. So the geometries within the geometry column of a data frame can be any shapely geometry. So you can they could be uniform. You could have each geometry in the column is a point in a particular one. You can mix them. You can have points in one or multi-points in another. So it doesn't enforce anything particular like that. So anything that can be represented, which is essentially a simple features geometry, anything that Shapely can handle, it can handle.
Follow up that question.
Yep.
So geometry field contains not only x, y, but including also the altitude as well? I'm thinking about the shape field in the GIS.
Yes, in a 2.5D sense, yes, and that's from the limitations of what Shapely can do. It's essentially it does all the computations as a 2D object, but each point can also have a z dimension associated with it. So you can have the quasi 2D, vector data with a z attribute is okay, but it doesn't, if you have a polygon that wraps around in a spiral, it still counts it as intersecting because the x and y are the same. It doesn't care about the z for the geometry operations, right? And that's essentially a simple features restriction. Yeah.
Oh, no other. Oh, there's one.
Is there anything you'd like to see in Pandas that you really, really want that just working on this?
That's a good question. You guys did a lot of what I wanted in the 0.13 release. So that really cleaned up the infrastructure for subclassing, and that helped a lot. I think I have to look more into the indexing infrastructure and see if it matches up what we want to do with spatial indexing. And I'm not quite convinced yet that the Pandas index will work as a spatial index, to do a real R tree. It might be, but I think we need to see if that's true, if the idea of the Pandas index is flexible enough. I think it may be now, but I haven't convinced myself that must be true.
I have one follow-on to that. So Panda indexes are properly indexed. It sounds like GeoPandas in geometry columns are not indexed. So if you need to do some sort of complicated shape join or whatever, you're going to be doing it element-wise?
Correct. If you're doing a spatial join, you have to do that element-wise currently. So that's one of the real performance limitations now. So to do that, fundamentally, to have an R tree or spatial index that can handle that kind of spatial join would be really cool, and that's what I was referring to in that question. Whether that happens as an actual Pandas index or if it's a separate attribute that it works with, one of those is certainly possible.
Kind of following up on that a bit. Kind of following up on that a bit. Would it, until such a feature is implemented natively in GeoPandas, would it be fairly easy to just simply export, two GeoPandas objects up to Postgre or something like that, and let Postgre do the spatial join and then get it back?
You certainly can. If you've got things that fit in memory and you've already got them in memory, you'd rather not have to do that, obviously. But the idea is that, similar to Pandas, is that you should be able to work with things in memory easily without having to use a database. If you're storing things in a database, great. But to use a database just to do the operations, we shouldn't have to do that, right? And we should be able to use the same libraries that PostGIS uses to do these kinds of things, right? And for example, the geometry operations that Shapely does are the same GEOS computations that PostGIS does, and we should be able to do that with indexing and joining as well.
I'm not that familiar with Pandas, so you must excuse me if this is a silly question, but you were saying earlier on that you hadn't thought of a case where you could, say, have a GeoPanel, but it was something that maybe if there was a reason for it, you could consider it. What about the concept of doing some sort of a time series representation? Because I can see uses for that, So that might be a nice way to extend this to multiple layers where each layer is a different time series.
Yeah, no, it's certainly, the difficulty is in working with it. Representing it wouldn't be that hard, but how do you actually do something with that? To have it be any more useful than just a dictionary of different panels, right? That's the question. It's certainly not fundamentally difficult to implement, yeah, but there are uses for it.
Okay, let's thank the speaker one more time.